class to demo to you guys. Obviously, it's not ready right now, but we're still going to be continuing to work on it. But to give you an idea of like, if you wanted to print your map one for one, this is one way to do it. Let's sorry, 3. Let me just hide these for now. Let me work like this. But yeah, I was trying to draw like a Pac-Man map, and I broke it up into different sections. Like this builds the outer perimeter.
Yeah.
This builds like these two little inlets over here and over here. And then all this mess is for these L-shaped blocks, L-shaped walls. And then I was going to try and populate like the insides with pellets for Pac-Man to pick up, but trying to find a way to do that that isn't just manually drawing a bunch of pellets is kind of annoying.
Well, there's a couple ways you could do it.
I mean, there is a way. I have a loop here that I was certain would work, but it's causing errors. Like it's just saying this symbol doesn't exist. Oh my, that's why.
Yeah.
Jesus Christ.
Little things always trip you up, especially when it doesn't have like the smart compiler stuff where it checks in the background.
Yeah.
Yeah.
I mean,
Honestly,
like that one, even a smart compiler wouldn't catch that because it's going to look for a variable toString, not a
okay.
method toString.
Yeah. But yeah, I did that differently.
Yeah.
For mine. Yeah, I literally just defined the bounds for like the corners for all of the different rooms.
Mm-hmm.
So what it does is it will
In between each corner, got it.
Well, it goes from one corner to the other, printing out the lines, and then it adds it to the array, building out the boxes.
Got it. Nice.
So it literally just traces everything that way, and then it can hop between spaces. So you could draw. I generalized it enough that it could theoretically draw any size as long as you put it in the inputs for row and column.
Nice.
And
That's
you
pretty good.
Give it the bounds for the boxes. So, I mean, pain in the ass to actually get all of those. First of all,
a little bit, yeah.
Other than that, I think it's relatively clean. Honestly, the room part was kind of annoying, but not nearly as bad. Getting the room descriptions to work. As just sort of a thing because we learned classes this last week.
That's what we're going to go into today. A lot of work with classes.
Yeah, I implemented a room class that can just handle a lot of this stuff. I'm mainly doing that so ahead of time so I can actually have it handle my enemy class, so I don't have to predefine each room. So it will just in that bounding box, it will drop an enemy, and then that'll be where they are, and it can handle a lot of that stuff from the main.
Mm-hmm.
Anyways, yeah, so I did that and built a character one, just FYI when you're grading. So
sure, nice. All right, today we've got 17 people on. Okay, cool. So we'll get started. Today is going to be a lot of demos because this is the point. A lot of you are already kind of like shaky. I shouldn't say a lot of you. A few of you are already kind of shaky, and I know that because I've talked to you. I'm a little shaky on everything we've covered so far. This is where like people either like get really into programming, or I just lose people completely. Classes can be one of those things. It's just very tricky for people, and it's hard to explain it without doing a bunch of demos. Because the general definitions I'll give, some people like it just they don't make the connection until they've just run it enough times. So up until this point, we've really covered variables. You guys are all pretty comfortable with variables and you understand how those work. We've covered stuff like arrays, which is a way for us to store multiple variables of the same type. We've also covered again, I think we've also covered methods, which are ways for us to delegates responsibility of performing certain functions to other things. Now, what we're going to get into is classes. And the analogy I like to use for classes is imagine your program as an office. Your main method is the office manager. The office manager's job is to make sure, kind of spot check with every department and make sure that things are running smoothly. The departments are like your classes. You've got your accounting department, your sales, your HR department. To further expand on the analogy, your HR department might have your accounting department might have like one person who's responsible for balancing sales receipts. One of them might be responsible for customer logs and whatnot, invoices, that sort of thing. Another one might be in charge of payroll. These three things fall under the purview of accounting. So, accounting class is the department in the office, and then these different things that they have to do: payroll, bookkeeping, and uh, you know, revenue or record collection. These three things could be different methods. So the way I like to analogy I like to use is the your program is the office, your classes are the departments, your methods within those classes are specific people working in that department. With that, and that's kind of like the analogy that you guys should kind of try to keep in mind, because as we're starting to move forward, you're gonna notice that in my programs, my main methods are pretty sparse. All that's really in here is going to be calls to other objects. The office manager just directs, hey, HR needs to do this, and nothing else for that happens here. There's minimum work done in the main method. The reason for that is you want to keep your main method clean and easy to read and follow and understand. The main method really is just the nucleus of your program. It's responsible for setting out these usually singular branches that branch off to a bunch of other things, like you know, uh, HR has or payroll has their accounting has their regular stuff that needs to be done. It makes a request to the accounting department, and the accounting department branches off into the different places. Like here's payroll, here's bookkeeping, here's sales, revenue, etc. Right? And it'll make more sense as I start programming examples. So what I'm going to build today, and this will hopefully help you guys out with your Pokemon, or sorry, your Pokemon, your it'll hopefully help you guys with your milestone 3 for your game stuff, because I'm going to be, for the next few weeks, I'm just going to be building little mini games inside of Java, text-based mini games. So for this one, I am going to build a little Pokemon encounter. So it'll be very similar to your combat encounter. And if you guys want to borrow elements of what I write for your combat loop, feel free. I encourage you guys to think about different ways to do it. Anything I show here in class is not like the way to do something. It's just one of many ways to do it. So here we go. I'm going to, in my Pokemon game, the way it's going to work is it's just going to be a combat loop, basically. We're just going to start out with, I'm going to make a driver class for it. In fact, let's make Pokemon. Make a folder there for it. It's just going to be a combat encounter. So we're going to start with oh god, I really can't talk today. I'm sorry. Sorry, I lost my train of thought. It's just going to be a back-to-back combat. So the player is going to have a Pokemon, and then they're going to face off against like maybe 2 or 3 enemy Pokemon in a row and see if they can survive. So I'm going to make a couple of different classes for these Pokemon. So we're going to have a Pikachu.java. The problem is, you guys are going to notice I'm building this. I'm going to reuse some of the variables. There's a way to even clarify this further. You can create what's called super classes, or parent classes is a better name for it. So instead of like having just a bunch of different Pokemon subsets, I'd have one class. Actually, you know what? We'll do it this way. Pokemon here. I'll rename this to Pokemon Demo. In the Pokemon Demo folder, we'll have different Pokemons. And then we'll have abilities. So I'm going to have Pikachu, Charmander, not a folder. Okay, my Pokemon game is just going to have these 4 Pokemon. Public class Bulbasaur. And whenever you create a class, what happens is, think of your class as kind of like a blueprint. You define a bunch of states and behaviors, and we'll get to what that is in a second here. But you'll define a bunch of states and behaviors for an object. And then once when you have the blueprint, whenever you call that, you need to do what's called create an instance of that class. So for instance, over here, I have my main class, right? I have my public class main. And here I created this variable named self is just an instance of the main class. So this self will contain stuff like public int I equals 0. And I can print out self.I self.I going to go ahead and in a little second get the output. I'll just stop that for now. See, we printed out I at 0. And if I change the I to 3, let's say, we'll have a printed out. There we go. I is equal to 3. So this is what's called a state of the class main. It's a state is something you can is a description, is a quantitative thing. It helps quantify some feature of that class. This method is a behavior of the class. It is something that the class does. The common example that people use with introducing classes is they'll have like dog.java, and they'll say, okay, let's create a class that describes a dog. What are some traits of a dog? What do you guys think are some traits that a dog has? What are some states of a dog?
It's color.
Yeah, string fur color. What else?
Maybe height.
Height. Yeah, sure. We'll say that one's double height. Earship, breed. Yeah, earship, breed. Yeah, we'll say breed. That's another one. We'll have an integer, age. He needs a name. The dog needs a name, obviously. Name. Maybe another descriptor could be like if the dog is male or female. Boolean is male. Right? These are some like very general states to describe a dog. Then we need some behaviors. What are some things that a dog does? A dog might bark. A dog will bark. Public void. They might run, right? Dylan is running through the fields. right? Might have a, yeah, they might fetch. Maybe we say public object fetch, and we'll object thing system out println I through the thing.toString. Name fetched it. And this is just kind of an abstraction here. I wouldn't get too hung up on what this object is. This method, oh, and then return object. Thing. Right, so I threw an object and the dog brings it back. Right, so there, that's one thing there. So these are some like behaviors the dog has. Someone had a question about what the clear function is. I'll get to that in a second. Behaviors and states. Okay, so we've defined the states and behaviors for our dog. One of the things that's remaining is we need a way to be able to create an instance of this dog class. Now, for this, who remembers from your 210 classes, what do we need? What do we use to create instances of a class, of an object? Because right now we've just defined a blueprint. How do we
you need a constructor, don't you?
We need a constructor, exactly. So there are two types of constructors. There's what's called a default constructor, and by default, there's a lot of ways to circumvent the default constructor. Usually, the constructor is used to set some initial state for the object. There is always a default constructor created in the background by Java, and it's usually just initialize these to null values or zero values. It depends on your version of Java. You don't necessarily need a default constructor unless you want something like, let's say by default, I want my dog to be modeled after my dog, or my brother's dog, more correctly, Lando, right? So I say public dog, and by default, I'm going to create Lando. Name equals Lando. For color is black. And then getters and setters are something else, Michelle, and we'll talk about that. Getters and setters aren't needed to initialize a method, but getters and setters allow you to access private variables. And you know what? Just to prove that point, we're gonna set all these to private variables. These are all gonna be privates, just so we can demonstrate getters and setters. And just to further demonstrate it, only the name is going to be public. Or actually, you know what? We'll keep the name private, and we'll keep these public because maybe I'm just thinking of it like, oh, if we look at a dog, we can probably tell what fur color it has and maybe guess what breed it is, but we probably don't know the dog's name by looking at it from a cursory glance. We probably can't, from a cursory glance, gather how tall it is or how old the dog is or whether it's a boy or a girl. These don't come from a cursory glance, right? So we'll go ahead and I'll finish this up. Height for my dog is, I don't know, he's like 6 foot. He's not 6 feet. I don't know how tall a dog usually is. We'll just put 3.5. That's just a dummy value. Age, he's 4. And then is male equals true. Lando is a boy. So now what we have is called the explicit constructor. This is when we want to create an avenue for the person, for the agent initializing this, creating an instance of this class. We want to give them a way to define states and behaviors for it. So what we do for the explicit constructor is we start giving a bunch of parameters: string name, string fur color, string breed, and these are all the parameters here are states of the class that we want the user to be able to set at the start of it. So because we're creating a dog from thin air, we want the creator to be able to identify all of these. String breed, double height, int age, Boolean is male. Now, observant people among you might notice, hold on, this is weird because our parameters are named the same thing as our local variables. How is Java going to know the difference? Well, very simply, by using the this keyword, we're telling Java we're referring to this instance's variable name. So in this case, this dot name refers to here, the name string of this class. And then when we say name without the this, it refers to the parameter. It's that simple. And then we just repeat that. This dot fur color is equal to fur color. This dot breed is equal to breed. This dot height is equal to height. This dot age is equal to age. This dot is male is equal to is male. So Michelle mentioned getters and setters. Because we have some private variables here, it means that the only person, the only entity that can change and see directly queried these values is this class. And what I mean by that is this. Let's say I create a new instance, dog Lando equals new dog. I use my default constructor here. And I say Lando dot, you see by default, it only allows me to access these two because these are the only public variables within that. If I say Lando dot breed, I can print out system out println. I will print out Lando's breed. Quick note: what this clear does is this is just a method that cleans out my output. So if I say something like, let's say I put it here, I print out the I and then I put it here. And it might actually be too fast to tell, but it's going to print out self.I, and then it's going to print out Lando's breed, which I didn't initialize. Lando breed equals Labrador. When I run it this time, it'll print out. And by the way, notice that I'm not writing the static keyword here. The reason for that is because I'm not calling this method directly from the main. I'm creating an instance of the main class. And from that instance, I'm calling the method. So that'll lead us into the conversation of what static means here in a second, but I just want to start things out simply with the dog demo. Come on. Why isn't this going? I'm gonna say can I find symbol dog? remove all this. Sorry, 1 second. It happened too fast for CSC, but as you can see, it cleared the terminal input before it printed out Labrador. And in fact, what I'll do is I'll have like a quick for I equals 0, I is less than 1e6. I hope I can do that in Java. Three printed out. I'm having it stall in here for a little bit, and then it's going to clear the output and then print out a Labrador. 4e10 might have been a little too big. Uh, 48. Come on. 3. Got to keep going for a little bit. And then, yeah, clear the output. So this, I literally just Googled how to clear or Java clear console output. And this was like the first article that came up when I Googled that. This is it. This, if you want to know more of what it is, we can make output clear, say whenever combat. Yeah. The combat this clear will help you a lot with your formatting your game. That way, instead of having a big line of constantly reprinting the map, it's just in the same screen area. So it'll definitely help you with formatting your thing a lot more. But this is it. And if you're curious about how it works, it goes into detail. But effectively, there's a key sequence you can use to clear a console screen, and this emulates that. That's all it is. Yeah, it does. Like if you wanted to, I could just make this a public static avoid clear and then call it directly from there. This thing here is independent of the context that it's in. In fact, I could just copy these two lines of code over and over every time I use it. I could just copy paste it there. But because the point of methods is to reduce the copy pasted code, I use a method instead. And again, like, yeah, it doesn't matter where you put this method. I can have multiple instances of it. It doesn't matter. This is just so that I have a way to clear the output. And because the main method, yeah, I just put it here in the main method just because for now. But Kevin, your question also makes me think that I don't know that you completely understand what a class is right now. So we'll just keep going with this demo. Anyways, here's Lando. I've created an object Lando, and then I'm going to create a different dog object. I'm going to say dog Snoopy is equal to new dog, and we're going to start going through everything here. So the name is Snoopy, fur color is white, breed is beagle, height, I don't know, like 2, 3, who knows, age 4, I'll say 5, is male, true. And now, and in fact, what I'm going to do is I'm going to create a new behavior. So there is a method that exists in all objects in Java called toString that formats the representation of that object as a string. There is a default one, so we're going to what's called override the default implementation of public string to string. What I'm going to do here is I'm going to return a string that is name is a color space read is string sex equals is male, boy, otherwise girl, male, female, is a color space between sex that is height, feet tall, and is age years old. So to show that, I say lambda.toString. And I say system out println Snoopy toString. I'm gonna run this thing. Actually, I'm gonna stop that. I'm gonna remove this part here. You guys will see what the toString method does. It's very, very useful for representing your data. I highly, highly recommend you guys get used to using it. It'll help you out a lot with your earlier assignments because a lot of those require printing out strings and formatting them in a certain way, and toString allows you to do that.
Just a real quick question. Because my instructor, well, she's Korean. She was trying to teach us the toString. I had a hard time to understand her. Can you go over toString, what it does real quick? Thank you.
I'm about to show what it does right here. So all I've done here is I've formed this. You guys understand thus far, like I've just built a really long string, right? You guys see that here? This is all I've done so far is just built a very, very long string. And this string uses all of the variables within this method. Why is this so slow today? Okay. I'm sick of this. This thing is so slow. Replit is so slow today. I'll just wait for intelligent. Okay, here we go. But essentially what toString does is it's just a method that exists in the object class in Java. There's like a hierarchy of why is I hate this new Windows update. Everything is so slow. There you go. There's a hierarchy of stuff. There's object at the top. This is like the base class for everything. And then object gets extended to other stuff. It might inherit that be adapted for like an array list object, for instance, or hell, even a scanner object, or like it allows us to create custom objects. In this case, dog. Right? The dog object that I created is a long descendant of the object class, and within this object class, is a method called toString. ToString method exists so that this custom class, we can represent it as a string. So literally, all that will be in the body is some some string will be dynamically built and returned to the caller. And because it shares a parent-child relationship with the object class, which is just by default how Java is set up, you can't change that. We have to use this @override command before toString. This is telling the compiler, hey, use my implementation for toString, not the default Java implementation for toString. And all toString is meant to do is to represent this object as a string. That's all it does. So that this way, we can print it out. All right, we're moving over here to IntelliJ. Apparently, it has been a while since I used it because it wants to move slow. But whoever asked the question about the toString, does that answer your question? Does that make it?
Thank you. Thank you. Yes, yes, it does. Thank you.
Unfortunately, the compiler or Replit doesn't want to. There we go. It's very finicky today. What's going on here? Variable color class dog fur color. Let's run it now. Once it compiles, see, Lando is a black male Labrador that is 3.5 feet tall and is 4 years old. Snoopy is a white male beagle that is 2.3 feet tall and is 5 years old. Right? So this is all the basics, almost all the basics. Let's have some setters and getters. Almost all the basics of classes covered. So because we have these private strings here, if we ever want to modify something in our class, we can't do it because of our because of this. And let's say, we'll just leave this as it is. We'll create a new class to demonstrate this character. Let's say we're building a video game and we have a character, right? Public class character. Let's say we have an MMO, okay? And in our MMO, we keep these private because we don't want other players changing this. We want to make sure we want to control who can change the names of our characters in the MMO. Private int level, and then we'll just say we'll just leave it at that, okay? So we've locked these variables so malicious users can't try to circumvent our logic to directly access these things and change these variables. We're doing what's called encapsulating it. And just assume we have constructors. Now we'll just create a... Actually, you know what? We don't have a constructor. This will just be this demonstrate setters and getters. So public void sets name. This dot name equals name. The setter does what it sounds like. It sets the value of a private variable. And public string get name. A getter does what you think it does. It returns the value that you're trying to get. In this case, name. This should be pretty easy for you guys because we've done so much work with methods up to this point that this should just be like a no-brainer. As soon as you understand what private variable means, meaning nothing outside of the class can access it directly, you understand immediately becomes obvious why you would need setters and getters, right? It lets us create different characters. It lets us access variables in a controlled way. Public int get level return level. And let's talk while we're here. I can't help you directly, Alex. I don't know what the issue you're getting with that is.
It doesn't throw an error. It just doesn't clear anything. So when it's called, it just sort of continues without any issue. I tried debugging it, and it just sort of goes through it and goes, "Oh, that's a thing," and then just ignores it. So I have no clue. Maybe it's just IntelliJ being weird.
Let's see. Maybe it doesn't work with everything. It might just be also that like IntelliJ not using outputs, not using it has like its own terminal that it outputs to. It doesn't maybe follow the normal output stuff. But let's see. A
Yeah. That's exactly what happens with me. It doesn't throw an error. It just goes, "Oh,
Yeah.
I'm gonna ignore that."
Well, to Google we go. IntelliJ clear output. IntelliJ clear output console in runtime. Okay, that's why. Yeah, this is just specific to IntelliJ. So
Okay.
when you run this in anything, when I run this in anything else, it'll work. And in fact, I'll demo it right now. Copy path. So if I say Java chapter 9, see, it worked. This is just IntelliJ's output itself. When you run it through the actual terminal, like I will, because when I run you guys' code, I use VS Code and I use my terminal to run your stuff. So for me, it'll work. And if you want to test it yourself, you're gonna have to use your terminal to test that output. Yeah, like that post said, this is, don't think of this as a terminal. Think of this as a log file, meaning every output, it just gets put into here as a log. It's not an actual terminal. Anyways, we'll just keep working on here in that case. So let's say I create a new character. Character 1 is equal to new character, and c1.set name. I should have recommended it. Yeah, there you go. Set name. Oops, not like that. Set name Turk. And then c1.set level. I'll start at level 2. And just to be consistent, let's have another toString. Public string toString. Override. Return. Name.toUpperCase. Oh, it's an MMO. It should also have a class. Give me a second. Sorry. I just realized I can't do this because that's a reserved word for Java. Player class, we'll call it. And we'll just keep these names the same. Let's see one that's set class, Paladin. All right. Level, space, class, or class to uppercase, then close caret bracket. And then if I say system out, println c1.2 string, okay, classes and character. It's player class, I guess we'll call it. Now if we run it, should work. Cool. See? There we go. We've demonstrated how to use constructors. We've demonstrated how to use setters and getters. Any questions about what we've covered so far? Anyone still kind of confused about what classes might be, what they're for, etc.?
Really quick, when you're doing the whole dog class thing, is it necessary, or was it necessary to create an explicit constructor, or can you stick with the default constructor?
That's a very good question. In most cases, it really depends on what you're building. In the case of the dog constructor, it is necessary, because otherwise, anytime we call this, it's just going to create Lando, right? This is the default constructor. By default, the dog constructor conforms to my dog, Lando. But what if you want to have your dog a Rover, right? I need to give you a way to be able to model Rover. What if someone else wants to have their dog, right? By default, it will only ever create Lando. So if you want people to be able to create their dogs, then yes, I 100% need to give an explicit constructor. However, if, say, by default, I'm trying to think of a good example for this. There are cases where by default you want things set a certain way, and then you want it to be able to be modified. You want these variables to be able to get modified by setters and getters. It really just depends on your implementation. But if you're asking for generalized rules, there's no real generalized rule for this kind of thing. I can't tell you 100% of the time you're going to need an explicit default constructor, or 100% of the time you're not going to. I will say this, I don't often use the default constructor, because one way around the default constructor is just to do this. Here we're setting default values for our variables. So once when we create an instance of this class, these are going to be when we create a instance of the class, these are going to be the default values set to these variables. So if I run this again, typo. If I run this project again, then you guys will see dog and class can be applied to given type. There we'll just You won't always get this error. Public dog. I'm just going to leave an empty default constructor so that Java, this compiler knows that there are, this is what's called overloading a method. Sometimes some compilers aren't smart enough to realize that, hey, even though there's no default constructor defined, there is still a default constructor. What the error I was getting there is saying, yo, you need to give me a bunch of parameters because all I've got is the explicit constructor. So I created a blank default constructor here to circumvent that. You won't always have to do this. Newer versions of Java are pretty good about this. But it's also not a bad habit to get in the hang of. I mean, this is another way you could do it, but really, generally what you do instead of doing this is what I had before, where you would have these values declared inside of your default constructor. Does that kind of answer your question, or did that just confuse you more?
Yeah, it did answer my question. It also answered another question I had. It was like, what's the advantage of using classes and objects and stuff when we can just create variables? But it's just like a method. It just saves you space when writing code, pretty much.
It saves you space when writing code, and it allows the reason you have this question is up till now you haven't been given any assignments that require you to create stuff like that. But if you think back to the combat loop, wouldn't that have been much easier if you could just have a separate class for a player and a separate class for and I'll demonstrate that right here. Like, so I'm gonna create like a mini Java loop right here, okay? And then we're gonna have let's call it combatants. Wouldn't it have been much easier if, and let's just say, I'll just keep these public for now. I should keep them private. Private string name. Make the name public. These decisions are just arbitrary. I'm just thinking of it for terms of demo. There's no real rhyme or reason to why I'm making some of these private or public. And max HP, current HP, and then private int strength dex in con, call it strength dex AC. So, and this one combatant int max HP, int strength, int dex, int AC. Okay, so I've got these variables, and I'm going to give a very quick description of how all these work. So a character has a strength and a dexterity. In my game, the way it works is I'm going to do it based off like almost like D&D. I'm going to roll a 20-sided dice, and then I'm going to, when the character makes an attack, he's going to roll a 20-sided dice and add his dex value to it. If that dex value meets or exceeds the target's AC or armor class, then the attack is a hit. And to do damage, they just apply their strength to their strength defines how much damage they do per swing. Okay, that's my system for my game. So I've created a constructor for the combatant. Now I'm going to create public int make attack. And in fact, on top of that, I'm going to also create a dice class. Just because. Please keep yourself muted if you don't have a question. Public class dice. And I'm going to say public int. First, I'm going to import Java util random. I'm going to say public int roll int dice type number of sides. And this is going to look very familiar to the dice stats lab. Return new random next int num sides plus 1. In each combatant, it's going to say, so we're going to do make attack. Return new dice roll. Actually, this import should actually be outside of the class. Private int num sides. This num sides is equal to number of sides. So we go back here. We're going to roll a d20. Roll. Right? Yep. So we create a new instance of a 20-sided dice, and then we have that dice roll. And we're going to add our dex to it. That is to make an attack. And we'll say public void take damage. Damage to take is going to be this, actually, current HP minus equals damage. And you'll have a public boolean is alive. Return current HP greater than 0. So if for whatever reason our current health ever falls to 0 or below, and the reason why we check for less than or equal to 0 and not just equal to 0 is, what if we have 5 health left and we take 6 damage, right? It's going to be -1. The game is, if we just check for if it's equal to 0, the game is going to think we're still alive, even though we're in negative health. So that's why we do it this way. Is alive, make attack, take damage, public int deal damage. I'll just say int get strength, return strength, because that's what we need to deal damage. Another Boolean method, public Boolean attack hits. Int attack return attack is greater than or equal to AC. So just to recap, the system, the way it works is anytime a character wants to make an attack, they roll a 20-sided dice right here and then add their dex to make an attack roll. If that attack value exceeds or meets their armor class or AC, then the attack counts as a hit. So that's what I built over here. I have built in this checker here to make sure that to check if the character is still alive. And then I've created this here to basically get their damage, because whenever a character makes a hit, their strength score is how much damage they will deal. And then here's another method to allow our character to take damage. So let's go. I'm just going to create another class called combat loop Java. Public class combat loop. And I'm going to have combatant player. And let's have an array of enemies. Combatant enemies. I'd say I want multiple enemy. I want to face up against multiple enemies. Public combat loop. So when we initialize our combat loop, we need to define who the player is. Player. So we'll go ahead and put in this dot player is equal to player. This dot enemies is equal to enemies. And then I'm going to have public void. It's going to run the combat loop. So while actually, to keep things simple, I'm just going to have one enemy. While player is alive and enemy is alive. So while they're both alive, we are going to actually, instead of even doing that, I'm going to say, I'm just going to keep this as an infinite loop for now. Int round equals 0. I'll say if round is even, then it's going to be the player's turn. Otherwise, it's the enemy's turn. And obviously, this is not like a total game. This is going to be more of a simulation because it's going to run automated. It's not going to ask the user for input. So obviously, this is not what I want for your game, but this is just a demo, right? And the whole point of this demo is to show how much easier and cleaner our combat loop might have been if we were able to use classes. So instead of having to do all the calculations, here, you guys will see in just a sec. It's not just only to be cleaner to read and write, but also it opens up more avenues. Because now I can define, let's say I wanted to make a strong attack, right? Like I can have here make attack, and I can have another one called make strong attack, where if the make strong attack hits, then maybe it deals more damage. Maybe they take a slight penalty to their attack roll, but if it hits, then they do a lot more damage, for instance. It allows me to define how specific abilities might work, because now I can define behaviors unique to the combatants. So here we go. And keep in mind, for all your different monster types, you can create different classes for all of them. Like, let's say you have a slime, and then you have a zombie, and you have a skeleton, and these all do different things. It's like Pokemon, right? I can create a class for Pikachu. I can create a class for Raichu. And in each of my rooms, in my dungeon, I can put the different Pokemon that are in each room for each combat encounter. But I digress. Let's get back to here.
Do you suppose that's how the creators of Pokemon did it?
I have no idea how they did it. They might have. So here's a object in game design. You don't use object-oriented programming. You use what's called component-based programming, which rather than defining, because if you think about, I don't want to get too far into it because it's a big concept and it's going to be really confusing for an intro class. But essentially, rather than creating full objects for every single thing, what you do is you define specific components and you compile those components together to make an enemy. Like for instance, we can define components to define some loose term object, some creature's health and defense value. Then we can have a bunch of components laying out there for the different abilities, and we can pull from those and create our Pokemon. It's a really, really interesting topic and a very interesting design philosophy, but it's something that's way outside the scope of this class. It's outside the scope of class of most of your classes until you get to like 413. Excuse me. In 413 is when you'll start talking about different design architectures. So you'll start kind of branching out from object-oriented design to more component-based systems or multi-threaded programming and stuff like that. But for the concept of this class, that question is a little bit outside the scope. It's possible that they might have for earlier versions of Pokemon, but object-based programming doesn't get used much in game design anymore. Anyway, so if it's the player's turn, actually, there's a much smarter way to do this. Combatant current combatant equal to round. If this is even, then it is the player. Otherwise, it is the enemy. And now we'll just refer to everything based off the current combatant. Combatant current target is equal to round divided by 2 equals 0. Enemy. And it's just going to be the opposite of this. So if it's the player's turn, the enemy is the target. If it's the enemy, the player is the target. So we're going to roll. We're going to say system out println current combatant dot is name public. Yeah. Dot name. Try. In fact, I'll just say int attack is equal to current combatant dot make attack. Cool. Attacks with the roll of so current combatant target current target attack. If current target how's that method called? Attack hits. Printf attack hits. Current combatant fails. Otherwise, it misses. And if it hits, then the current target is going to take damage. Did I abbreviate that? Or take damage equal to current combatant dot get strength. So we make the attack, and after that, we're going to check if current target is alive. So if the current target is dead, sim out printf has killed current combatant, current targets. And that'll be the end of the, actually we'll even say return, because that'll be the end of the combat loop. And then this method will stop executing at that point. Otherwise, round plus. Otherwise, we go to the new round. Cool. So what I'm going to do over here is I'm going to create two combatants. Combatants, player, new combatants. Name Turk, max HP, just roll 20, and strength. I'll do 3, 4, and AC 16. We'll do a new combatant. Enemy will be a zombie. Max HP of 25, 2 strength, 3 dex, and 14 armor class. And these numbers are kind of arbitrary, but then we'll say new combat loop, player, enemy, run. All right. So if we run this now, the role and class dice cannot be applied to given type. Oh. Why is it doing that? Oh, duh. Need to put that name here. So by default, when you just try to print out a class, it'll say the class at this memory address. But obviously we want to print out the name because the memory address, the class at that memory address is meaningless to us. Yeah, I killed a zombie. See, Turk attacks zombie with a roll of 14. The attack hits. Zombie attacks. The attack misses. And there's our combat loop. So I know this is like a really just like boom, 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 fast demo, but is this kind of like getting some wheels turning in you guys' head about how using classes and using objects is just much, much, much superior to a single class with just a bunch of variables? Because all those variables you would have initialized for each character, we have it over here, abstracted away to this class. I mean, if we go back to the main class and we ignore all the demo stuff that I created up until now, this is basically anytime we run into a combat situation, this is basically all we have to do. We just initialize our character objects and then we put those into a combat loop together. It's 3 lines. That's the whole combat loop, and we can do this every single time. You can have these combatant stuff initialized, saved into a room. Like you could have a room class, and then you could just have like a combatant enemies in room. You'll have that variable there, and then in your public, you'll pass in an array of the enemies in the room. So whenever you encounter a room object, you have a bunch of combatants available. You make some little tweaks in your logic for your combat loop to allow for multiple enemies to go at a time, or for multiple enemies, for multiple characters to take turns with each other. And then, yeah, that's all you do. Your combat loop logic is defined here. It's not interfering with anything else. Everything is in its place. So whenever you're going to go make a change, you just go to that class, tweak the logic that needs tweaking. You don't need to change a million other things in a bunch of places in your code. It makes debugging very easy. It makes maintaining very easy. And it just opens up a lot of opportunities for things to interact with each other. It's okay if you don't totally see all these now. I'll be doing a lot more demos over the next couple of weeks to demonstrate this stuff. But yeah, this is your first step in object-oriented programming. This is really where the meat and potatoes of it come in.
I do. Sorry, I have a
Yeah.
quick question. I tried running my code for my exploration because I used Java files, like classes, along with my normal one. So when I tried to run it, it threw an error saying that, oh, I don't know what a room or a character is, even though those are the classes that I sort of have it using. So I was wondering if there's some weird passing thing that IntelliJ does in the background, but doesn't happen normally.
It could. Did you put them in separate folders? Did you create different
No, it's
packages?
all in the same source folder.
Okay.
It's just for some reason it just doesn't see them, and I don't know what's going wrong. So yeah,
we can talk about it after class. If you want to stick around, I can help you
okay, yeah,
debug
that would be helpful.
because that involves me seeing your code.
Yeah, of course. Yeah, I just want to make sure because you're going to be grading it command line, so I was double checking that it worked command line.
I can figure out that command line stuff. Don't worry about that.
Okay.
If you're not able to get it to work on your terminal, it's not a big deal. I'll figure out a way to get it to work on my end.
Okay, I was just concerned about that because my whole goal is to try to get it so you can just plug it in and play it.
Yeah.
Like, that's the goal of most programming.
No, yeah, definitely.
End user has little to nothing to do.
Yeah, don't worry about it too much. It could just be like maybe you can't run it directly to the Java file. I might have to compile it and whatnot, but it's totally fine. Don't worry about it. I'll figure it out.
No worries. Yeah, but after class, I would like to actually figure that out myself, so I can actually run it and test it that way too. But
well, I was gonna do some Google. If I ran into issues, I was just gonna Google how to fix it, or how to do it. I don't know it off the top of my head right now.
Yeah.
Because usually when I run Java stuff, like I haven't had to do this kind of thing in a while because I haven't had to program with Java for a while. And usually when I do create stuff with Java, I package it to a jar file, which is a Java executable file that you just send out. So
yeah, that's probably what I need to do to get it to run.
You don't have to do that, no. Okay. You can if you want, but I haven't configured iLearn to accept jar files, and I'm not gonna change that.
Yeah, well, I'm sending it as a zip with everything in it anyways. But yeah.
Yeah, I mean that is definitely one thing you could do. You could try to make it into a jar file and then zip that in with the rest of your code. But you could also just send me your source file. That's totally okay too, or your source folder.
That's literally what I did when I sent you Project 2 or Milestone 2. I was just trying to figure out how I can run it command line so I can
Gotcha.
check that my output still works command line.
That might be some Googling you have to do.
Yeah. Anyways. Yeah, I wouldn't mind you to look over my code, but we can talk about that after class or whatever.
Any other questions about the demo from today?
Out of curiosity, will you be uploading this code into iLearn?
Yeah, sure, I can share it. I'll do it right now, actually.
I thought that maybe that if you would upload it, I could like look back at it and see how it works again.
Yeah, I'm trying to remember how I did the last, because I don't want to invite you guys to do it. Chapter. When I post it, you guys should be able to see the, it'll load the executable as well as files. It's being slow. I guess something's up with their servers today. But here. And the demo that I'll be doing with the second class might also be different. I'll probably try and like just build a Pokemon game there too. So I encourage you guys to check out that class's lecture as well. Yeah, because there might be like different demo code that I post up there. So definitely like play around with both, and they're gonna have to like look up both lectures too. So it's not just you guys having to watch 2 lectures. I'll advise that they watch both lectures as well. Okay. Any other questions? Okay. If there's no other questions, then I'm glad you guys are feeling a little more. I hope you guys are feeling a little more comfortable with classes and objects. Kevin, I'm glad I could be of help with that. Yeah, just keep practicing, guys. That's really the big thing. I encourage you guys to go out on YouTube. This guy, Derek Banas, is super, super helpful. And he's got one super video that goes over all of Java. He's got these really nice 30-minute videos for learning languages. These kinds of things are better when you like know at least one language in and out, and you can do it. But he has a whole video series of just different stuff that he goes over. Like, he goes over classes and objects in this video. It's a 15-minute video where he gives you like different examples of different, like similar to what I did, but he probably has a different way of explaining it that might resonate better with you. I really, really encourage you guys to take this time now in your CS careers where your projects are really easy and really quick and your teachers are very lenient with you to really just do as much independent research as possible, because it becomes much harder to do it later on when your courses begin to get harder, your classwork, your expectations are a little bit higher, your projects themselves are more difficult. Trying to learn a concept while also putting it to practice at the same time is not easy. Normally, you have to learn something before you can really put it into practice. So I encourage you guys really take this time, go out, do a lot of reading, watch a lot of videos, um, watch tutorials, work on stuff, tinker around with this stuff, because it's not gonna. I notice in a lot of new programmers, it can feel like this stuff can feel very scary and intimidating, and that kind of makes you lock up, and you don't really like mess around and tinker with this stuff. You're too afraid to make mistakes, so you don't try things, and then you come to a point where like you've settled into this groove maybe, but or maybe like you just never settled into it at all, and it just becomes harder and harder and harder as time goes on. This is really the time that I think you guys should really make those mistakes. Go out there. Anyways, that's my little preachy ramble for the morning.
Do you think that an internship would help us, or do you think it's a bit of a stretch to do an internship right after an introductory class?
Go for it. You should always go for internship and stuff like that. There's never there's a motivational quote that I saw a while back. It's like never. What was it? It was something like, don't, when you're setting your goals or something like that, don't put conditions to when you'll go for stuff. Like always go for stuff that pushes you. The worst thing that's going to happen is you're going to apply for internships and they're going to say no. You're going to go to an internship, you'll make mistakes, there'll be people there who are prepared for you to make mistakes, and they'll help you through it, and you'll have a really, really good experience. You'll have a really good learning experience from that. So if you're thinking about internships, go for it. There's no reason not to. There's never a time to wait. When I did my first internship, I objectively wasn't ready to start working for code at a production level, but I learned a lot from doing it. Any other questions?
If I have any questions about internships and software development in general, I can reach you on Discord, right?
Yeah. I might not always respond right away, but you can definitely private message me and we can talk about that.
Okay, yeah, because I don't want to keep the class.